Okay, now we're doing chapter 3, number 27. It talks about a race car on a racetrack going 44 meters per second and then slowing down at a constant rate. That's a little confusing, but what they mean is that acceleration is a constant rate to a velocity of 22 meters per second, and that takes 11 seconds. And how far does it go? Okay, so if we're writing down what the problem gives us, we know initial velocity is the faster one this time. Final velocity is only 22 meters per second. The time that takes is 11 seconds. Okay, and they're asking for how far, meaning really the change in position or displacement, right? Okay. Interesting, though, that we're kind of missing acceleration. They don't tell us what it is. They just say that it accelerates slows down at a constant rate. So we don't know what acceleration is. So if I go looking for a formula that lets me use VI, VF, delta T to find delta D, let's do that. Let's kind of go through the formula choices here. This first one doesn't have D in it anywhere, so doesn't help me out unless I'm looking for acceleration. Because I do have these, and I know delta T is really that stuff, okay? Same here, there's no D in here at all. I know all these things, don't know acceleration. Here's one with D's in it, which looks good. I don't know this. DI means where did the car start? And it's totally fine to just say, well, if they don't tell me where it started, I could just say, let's imagine that where it started is the origin. Okay? So I could just say, sure, I know that. And I know these things. But the problem is I don't know acceleration. And then here, here's a good one, right? But again, I have two unknowns. So I don't have a single equation I can solve for to get the answer. Well, what I can do though, all of these formulas have A in them. So I can solve, I do have enough information to solve for what the A is, what acceleration is. And then I can plug in A into, one of the other equations and solve for how far the car has gone. Okay, so this is a two-step problem. So let's solve for acceleration first. We can let's just use this one because it's already solved for it. So I'm saying average acceleration, that's what the line means, equals change in velocity over change in time. Okay, and here, when I do change in velocity, I'm always doing final minus initial. Okay, so at the end, it's going 22 meters per second. At the beginning, it was going 44. The change in time is the 11 seconds. Okay, so then I'm going to end up with negative 22 over 11, which is going to be negative 2. So that negative is important. I need to keep that around. Okay, so now I know negative 2. I'm putting 2.0 because I do have two sig figs here that I want to keep around. Okay, so this is kind of like the first thing I need. It's not what they were asking me for. Okay, now that I know A, I could use either of these equations, either this one or this one, because now both of those will have only one unknown. Okay, so let's do that. If you want to try doing the one I don't pick, that's totally fine. And I need to zoom out here for a second. Okay, so now let's say I'm gonna use this one now. Then I'm going to say its final position is equal to initial position plus initial velocity times time plus 1/2 acceleration times time squared. Okay, and I know that now it looks like there's a TF in here, and that's not on my given list. But remember, this just means like that the final time is 11 seconds after the initial time. So I can use 11 in there. Okay, so now I'm going to say final position is wherever I started plus initial velocity was 44 times 11. Okay, and watch carefully here. I'm just making sure I don't lose track of any addition signs. Okay, and then plus 1/2 times the acceleration is -2 times 11 seconds again, squared though. Don't forget the squared. Okay, so you could do all that at once in your calculator. I'm just going to do it one term at a time. So here, I get 0. I'm going to leave that term out. Plus 484. And look, the seconds cancel. That's good. Now I only have meters left, which is good because I'm looking for the position. Technically, we'd keep only 2 sig figs, so I'm just going to mark a line over the 8 to show I need to round that later on. Okay. Plus, if I do this term, I get negative 121 meters, and same, this should just be 2 sig figs, so I would technically round that off to negative 120. Okay, so that's why the negative sign is really important not to lose track of that, because if you forget to copy it down, you'll get a different answer. Okay, so then when we add that all up, we get a number to the tens place plus another number to the tens place. We're going to round the answer to the tens place, which I get 360 meters as our final answer. And that's like, 100 meters is about a football field. But that's a long ways because it's 3 football fields basically. But we are talking about a race car that's going very quickly. So I think that makes sense.